I've been involved in the Critical Skills program since 1992 and have been a master teacher since 1993. Since getting involved in the CS program, I've been committed to incorporating the CS model into my classroom practice. I don't think it would be an overstatement to say that I was completely sold from the first day of my original CS Institute. I remember that I came into my original institute primed and ready. After my 10th year of what most people reported was a successful physics teaching career, which consisted of a rather traditional lecture and demo science classroom, and I loved being the sage on the stage, I still felt unsatisfied. Although classes were great and students were happy, I knew a couple of disturbing facts. One, what I was teaching the students disappeared as soon as they walked out the door of my classroom. They didn't really grasp the whole world implications and applications of what I was teaching. And two, what I was teaching the students was very unlikely to survive the journey into their next science class, even if it was a physics class. Thus, I had begun my adventure exploring cooperative learning, authentic assessment, teaching critical thinking, outcome-based education, and more. I wanted to incorporate all of these things into my classes. And even with all of the positive things that these initiatives brought to my teaching, I still felt that something was missing. I had difficulty making it all fit together. And that is what critical skills did for me. It's like knowing the picture on the front of the jigsaw puzzle box. I could now internalize where all the pieces of the puzzle fit. But even then, it took me a couple of years of practice to realize the true strength of the CS model. Its unified vision of the creation of an authentic, collaborative problem-solving community within the classroom, driven by standards and using the framework of experiential learning, allowed the development of so much more than curricular understanding. After all, the program began when stakeholders were asked, what do we want our students to know, be able to do, and be like after they leave the classroom? This question began the development of the list of critical skills and fundamental dispositions that all people recognize as vital. The vignette that you see shows a brief example of one of my physics classrooms with a focus on the disposition of ownership, as the students work on a challenge called Massing the Universe that targets essential knowledge areas related to Newton's laws of gravitation and how they apply to the universe, showing real-life applications of the information. As a way of developing positive interdependence, I tend to transition to whole class challenges as soon as I think the students are ready, requiring the class to organize to address the problem as a team and distribute the tasks accordingly among work groups of various sizes. Also, in order to stress authenticity, I tend to make almost everything a scenario to stress how the knowledge is used by real people in real contexts. Incidentally, one of the things I've found is that challenges are a great way to reinforce skills and to introduce information at the recall level. But skills and knowledge that are likely to involve active coaching and cognitive levels above recall are probably best introduced in more traditional activities, though the experiential learning cycle is still a crucial component of this learning within the context of a collaborative problem-solving classroom. This is a relatively novice class in terms of the CS model. We're about mid-semester. We had previously done a few rather low-stakes challenges that served as the basis for this work. The class had developed standard operating procedures for tackling a whole class challenge. But this was the first time that I let them loose, mostly on their own, after the initial introduction. They were starting to take ownership of their learning, but it seemed like it was physically arranged in day-to-day table groups of 4 to 5, which I regularly randomly shuffled so as to encourage the idea that they could work with anyone, and that small groups were merely for the convenience of getting day-to-day tasks done, things like sharing and comparing homework problems, working together on some lab investigations, and so forth, things that might be called traditional classroom activities. I want to start off to kind of talk a little bit about a particular skill that I think would really be valuable for us to focus on a little bit during these next 3 days. And that skill is the idea of ownership, taking responsibility for your own learning. And what I'd like to do, because I'm not convinced completely that we've done super jobs with that so far yet. I mean, we've done really nice work in lots of different things, but I still get a sense that you're really relying a lot, particularly on me, instead of on each other and on yourself. And I'd really like to kind of address what that really looks like. However, to start with in the challenge, I wanted to have them think of themselves as a single, unified group. Thus I had them circle up, actually semicircle, so as to facilitate a whole group discussion to start the challenge. Incidentally, this classroom was far from ideal in terms of accomplishing this, but we made it happen. If everybody, you won't need to bring anything with you right now, but conceivably you might want your notebook and something to write with. So if everybody could grab your notebook and something to write with, and probably the challenge sheet too, just stick that in there. And if you could all stand up and frame the challenge with the idea of ownership. We worked to create a looks like, sounds like T-chart via a sweep for each column. Many of the concepts may not be what I would normally include under the title ownership, but I let them stand as stated. Whether the behaviors listed were satisfactorily organized and categorized does not distract from the value of the behaviors. Students are rarely given the opportunity to identify for themselves the behaviors that make things go well. This actually will look like. I like to think of it as, suppose you were a fly on the wall and you were watching what was happening in the room. Or maybe you're not a fly, but just a person, a real person that comes and stands at the doorway and looks into the room. And what we're looking for is evidence that would lead that person to say, those people in that room are taking ownership of their own learning. Just by looking. So what would they see? What might they actually hear? After we completed the T-chart, I stepped out of the process and let them organize themselves. I'm in the back of the room taking lots of notes on what's going on. This stage is my favorite one of the challenge, where they attempt to figure out the pieces of the puzzle and try to organize themselves to accomplish the challenge. Because they're in a semicircle, the whole group discussion is facilitated. Often groups will try to short-circuit the step of circling up, and this becomes a powerful topic for the debriefing at the end because it usually leads to people being left out of the discussion. As they quickly realized, it's more efficient to have separate work groups, so they rather quickly decide to divide up the tasks. It perhaps helped that I had struck the challenge into 4 separate tasks that needed to be accomplished. They decided to volunteer for various tasks, and then...
Wait, do we want to split into groups, or do we want to do everything together?
Because if we do everything together, we seem to make it stuff done like quite as quickly.
It's more efficient to have the separate.
There's 4 groups. Right? It's always good.
Yeah, but we can still check with other groups, but we only have a little over a day. We should just volunteer for different parts of it then.
So how many people are there?
Yes. 11.
Okay, so
3.
And we're missing Kira.
3?
So.
Yeah.
3.
Okay.
No, wait, it's
Alright,
going to be
so
3 and 2 then. We have 4 programs.
Yeah, but we're missing Kira, so
Yeah, so she's gonna
Yeah, that's true.
too.
Alright.
So we should just make groups.
So we should do.
Okay.
So
We'll do number 1.
They split up into their groups. You can hear the groups interacting, setting deadlines for themselves, providing ways of sharing information when outside of class, still showing that they think of themselves as a whole group. Positive interdependence.
Should we end as a group?
To be fair, pretty bad.
okay, everybody try to have at least your research done by tomorrow.
Do you guys have Gmail?
Yeah, we'll try to
And
do that
if
with
you
that.
guys have Gmail, then you can just share a presentation.
Here you'll see the class sharing their progress and checking on the correctness of the ideas. The girl in the blue dress has been chosen as the overall facilitator to help the class accomplish its goals. Very heartening to see them interacting and sharing like this. They suggest a strategy for facilitating the sharing of ideas and checking on work. Lots of ownership of the process going on here.
There's just one big table and we can just ask questions across it.
Yeah.
I feel like that'd be easier than just having our.
But we will have to spend time to put the tables
It
and
will
put them
take
back.
5
It's
seconds.
probably not gonna take a lot of time at all.
All right. Should we just maybe hold the with you?
Even when students are quite adept at organizing themselves and taking ownership of the process, with skill-based subjects, it's really helpful to provide nudges to help them from following misconceptions down a blind alley. In physics, the tendency of even very talented students to misapply ideas and use naive understandings is well documented. Thus, gentle coaching, stickies, timeouts, etc., to ensure they stay on track are often helpful. They also have the opportunity to ask me for mini lectures if they realize they're stuck on something, but I'm mostly sitting back and taking notes. A little comment on taking narrative notes. I found that creating a very simple Google form with fields for name and comment works really well. The results are loaded into a timestamp spreadsheet that I can quickly sort by student or by time sequence, depending on the need. The students really like seeing the comments they've made during the challenge. This also helps me see whether I've taken notes on every single student during a particular day.
Over G? Yeah.
The use of whiteboards sized for desk work has been an incredibly powerful tweak to my classroom practice. It allows students to rapidly share info and give each other feedback. Very rich conversations happen around the whiteboards without using up a lot of poster paper.
So you can also do B squared. But that's not the...
The challenge was set up as a scenario in which the students acted as research specialists in a media company and were to end up presenting their work for approval to a board of directors. Because this was the first real time they had worked on a relatively unstructured whole class challenge, I decided to use a small collection of science faculty, including myself, as the audience. This ups the challenge a little, but not as much as a larger outside audience. It's routine for me to wait at the door until we have been meted, greeted, and seated, an important part of them taking real ownership of the class. We developed a standard operating procedure for organizing a presentation. They're making use of this procedure as they introduce the topic and themselves before moving into the meat of the ideas.
C block class. We worked with the mass of the universe. We found different numbers before the project, which we used in order to find what we were looking for, which is we split up into different groups to solve the problem at hand, and these are my teammates.
Something that students in physics classes struggle with, and I suspect this is true in most technical subjects, especially at first, is that when they communicate the results of their findings, that they tend to focus on the details of the formulas and calculations, which usually doesn't communicate all that well to the audience. The students did a very fine job of using authentic data and physics ideas to accomplish all the tasks, and the feedback celebrated this. But the feedback also pointed out that what I call flying equations often doesn't provide much clarity. A rich source of debriefing to target what effectively communicating ideas to a non-technical audience will result.
First, Katie, Kayla, and I will be talking about how we found the masses of two binary stars. So in our diagram
So
here.
first we had a planet. So I'll just draw it here. So and there was a
In the
isolated.
galaxy by finding Well, what we first found was the visual mass, and that was
We knew that what G equals, what T equals, and what C equals, so we just filled it into this formula, Kepler's third law, and then we were able to find out.
How we found A is just the semi-major axis. We had to convert 1,000 AU into meters.
Debriefing is often the step most often skipped over in the name of time, but it's probably the most important step in terms of solidifying the learning, especially with respect to the skills and dispositions. As a way of developing ownership, I offered the opportunity to debrief back to the students, the first time that they had been given this chance. I also stress that debriefing is self-directed, that the operative pronouns are I and we, whereas feedback is other-directed, where the operative pronoun is you. They tend to like to get into feedback really quickly as opposed to debriefing, where they're really looking at their own processes, skills, and understandings. Yourself. Somebody like to run it? Thank you, Katie.
Oh, wow. Assess.
Here, the facilitator runs an okay next time sweep debrief, something that we had modeled well before. There are many ways to debrief, but this simple and effective procedure is something the students can easily run themselves. It's important to emphasize that everyone provides at least one idea during the sweep, and you can hear one person suggesting that they don't do a sweep, which was quickly vetoed by the students as not being part of the procedure. A small success. And that okay comes first, and that next time...
Scientists. Do okay.
teamwork.
Katie.
You're welcome.
Strategy.
No,
Yeah.
sweep the room.
How we solve
Yeah,
the
let's
problem.
actually do a sweep.
No.
No, because
Yeah.
not everyone
Yes,
comes
yes,
up with
yes.
ideas like right on
Okay,
the
well
spot.
then nobody, can I start then?
All right.
Strategy.
And what was our strategy?
To split into groups.
That wasn't part of it.
Do you know how to? Why?
Kira.
I think we did a really good job communicating like out of class, not just, because it's kind of hard for all of us to, and the fact that we got that PowerPoint together, all of us, I thought that was
And I would like to say that inside of class, the mini groups communicated well with the group as a
After
whole.
the debrief, I led a discussion on the correctness of the content, which was pretty solid, and talked about next steps for the class based on their debrief, in the spirit of what, so what, and now what. I pointed out the features of their looks like, sounds like list that are probably most connected to the idea of ownership, analyzing how well things went. We explored changes to our standard operating procedures based on the debrief. A very satisfying process.